Hello guys, welcome back to another past paper review video of Newton's Academy. Today we'll be looking at question 3. The question reads, the table shows the data collected for 3 organic compounds A, B, and C with different functional groups during a practical investigation. 3.1, name the following in this investigation: the independent variable, the dependent variable, and the control variable. Okay, so a way to remember which one is which: the independent variable is basically what they are changing throughout the experiment. Okay, so in the question they've already kind of told you the answer. They've said with different functional groups. So 3.1.1 functional groups. 3.1.2 the dependent variable. Dependent variable is what is being measured in the experiment, and in this case here melting points is being measured. Okay, so question 3.1.2 melting point. Question 3.1.3 the control variable. The control variable is what is being kept constant throughout the experiment. So in this case here, what is being kept constant is, if you look at compound A, we have 2 carbon atoms in it. Compound B, again 2 carbon atoms. Compound C, again 2 carbon atoms. So in this case here, the number of carbon atoms are being kept constant. So 3.1.3 the number of carbon atoms. 3.2 write down the homologous series to which compound C belongs. Okay, so there are a few ways to answer this type of questions. The one would be to look at the formula that they've given and just simply pick out what do you think is the homologous series to which it belongs. Okay, and that will come with some practice. The second way is to use the general formula of the homologous series. So every homologous series has its general formula. So you're going to count the number of carbons, the number of oxygens, and the number of hydrogens, and you're going to see if it fits within one of those general formulas. The third way is to simply draw it out and try and use some visual analysis to see if you recognize which homologous series it belongs to. Okay, so in this case here, compound C, it has that 2 O's in it, so the 2 oxygens. So to me, it's either going to be a carboxylic acid or an ester. Okay, and because the 2 oxygens fall after the last carbon and not between 2 carbons, it's telling me that it's not going to be an ester, because an ester would have had the oxygen between the 2 carbons. It's telling me it's going to be a carboxylic acid. Okay, so 3.2, write down the homologous series to which compound C belongs. It's carboxylic acids. 3.3, write down the general formula for compound A. Okay, so again, we need to identify what compound A is. So you can use the general formula, which is what the question is asking. You can draw it out, or if you can recognize it simply by looking at it, you can do that too. So in this case here, I'm just going to draw it out. So it's a 2 carbon atom chain with 3 around it. Okay, and we're going to count the number of carbons. The number of carbons is 2. The number of hydrogens is 6. So it conforms to the formula CnH2n plus 2, which is basically an alkane. 3.4, describe the trend in the melting points from A to C as shown in the table below. So here it's just for 2 marks. It's 2 very easy marks. You're just simply going to say, if you look at compound A, it starts off at negative 183.3 and compound C is 16.6. So you can see that there is a dramatic increase in the melting points there. So 3.4, the melting points increases from A to C. And as simple as that, you get 2 marks. 3.5, a little bit more work needs to be put into this. The question reads, explain the trend in question 3.4 above. Make reference to intermolecular forces and energy involved. So just as a general method of answering these types of questions, what you're going to do is as follows. You're going to state the name of the homologous series of the compound. So you're going to say, example, compound A belongs to this homologous series. And then secondly, you're going to state what type of intermolecular forces are present there. So example, you're going to say compound A is an alkane and it has London forces. Okay, you're going to do the same thing with compound B. Okay, let's say compound B is an alcohol. So you're going to say compound B is an alcohol and it has London forces and hydrogen bonding. After that, once you've stated the homologous series and the type of intermolecular forces, you are going to state which intermolecular force is stronger between the two. Okay, so you'll say thereafter compound B's intermolecular forces are stronger than compound A's due to hydrogen bonding. So you must give that reason, due to hydrogen bonding. Okay, thereafter you're going to make reference to the energy. You're going to say therefore a greater amount of energy is needed to break the bonds in break the intermolecular forces in compound B. Okay, and after that you're going to conclude what the question is asking. So in this specific example, it's going to be melting points. So you're going to say therefore compound B has a higher melting point than compound A. So just as a recap, we're going to start off with the homologous series. We're going to state the type of intermolecular forces. We're going to state which intermolecular forces are stronger, and we're going to state which needs more energy. And then we're going to conclude on to which one has the higher melting point, boiling point, or viscosity, etc. Okay, so let's answer this question. The question reads, explain the trend in question 3.4 above, make reference to intermolecular forces and energy involved, and it's for 5 marks. So again, we're going to follow the method that I have given. Compound A is an alkane with London forces. Compound B is an alcohol with London forces and hydrogen bonding. Compound C is a carboxylic acid with London forces and hydrogen bonding. Okay, next is to start comparing. So I'm going to start with compound C and compare it to compound B. So compound C's intermolecular forces are greater than compound B's due to it having 2 sites for hydrogen bonding. Therefore, a greater amount of energy is needed to break the intermolecular forces, giving it a higher melting point. Okay, so I've compared already compound C and B. Now I'm going to compare compound B and compound A. Compound B's intermolecular forces are greater than compound A's due to hydrogen bonding. Hence, more energy is needed to break the intermolecular forces in B. Hence, it has a greater melting point than compound A. Okay, and finish from there. So we've compared compound C to compound B and compound B to compound A. So we've explained the trend. Okay, I hope this makes sense to you guys.